We're going to go ahead and take a look at logarithms and properties of logarithms. That's kind of why we have logs in the background of this image here. Just a little bit of a pun there for you. Now, just to review, if we had 7 raised to some power equals 54, we're trying to figure out what power would that have to be. We know it's not a nice, neat number because 7 squared is 49. Well, 7 cubed is way more than that. So 7 to some unknown power equals 54 also means log base 7 of 54 equals that unknown number. A logarithm just represents an exponent that you're looking for. So any logarithm is an exponent. Logarithms are often used when you're dealing with science, whether you're dealing with really big numbers like the distances in space or really tiny numbers. So there is application to logarithms. Probably more applications to logarithms than some of the things you've learned. And we can talk more about some of that in class if you want. But for right now, I'd like you to go ahead. There's 8 different statements up here at the top of the page. Type the left side into your calculator. Type the right side into your calculator. And we want to know if they are equal. So I'll type in the left side. And then I'll type in the right side. Definitely not the same. So we know that that one is a false statement. So what I'd like you to do is to go ahead and pause the video and type all of these in and write down true or false next to each statement. As we look at this property here, that ends up being a true statement. This one here is a false statement. This one here is false. The top right one is false. Second from the top on the right is true, false, and then we have true. The 3 that are true lead us to properties of logarithms. Based on what we saw up above, a log of 2 things multiplied, you could break it apart and go log of the first plus log of the second. You might be wondering, well, why can we do that? Well, remember, we're dealing with logarithms, which represent exponents. Remember, when you were multiplying your bases, you needed to add your exponents. So multiplying our bases is kind of what we're doing here on the left, which leads us to adding exponents, and our logs are exponents. On the top right over here, a log of 2 things divided, you take the log of the first minus the log of the second. And that's related to the idea with exponents that when you are dividing your bases, that you subtract your exponents. This one here, remember, log base a of c is an exponent. So we really have an exponent raised to an exponent. And that's related to what we have down below. An exponent raised to an exponent. Remember, we multiply them. So this log base a of u is an exponent. C is an exponent. So we have to multiply log base a of u times our other exponent of c. So it's related to those properties of exponents since logarithms represent exponents. So let's start using those properties of logarithms to work with some problems. Here we have log base 5 of 250. We have information about log base 5 of 2. Since we're also looking at log base 5, we need to somehow look at 250 and try to rewrite it in terms of 2's and 5's. Well, 250 is really just a 5 to the third times another 2. We now have a log of 2 things multiplied. According to our properties, we can go log of the first thing plus log of the second thing. Now, you should remember about this right here, that log base 5 of 5 cubed ends up being 3. You might be wondering why. Well, our base of 5 to some unknown power has to be equal to 5 cubed. Well, 5 to what power is 5 cubed? That's 3. Log base 5 of 2, we have the approximation up here, so we'll plug that in. Then all we have to do is add them together, and we have our approximation. Now, down below here, you're given information about log base 6 of 8 and log base 6 of 32. So you want to take a look at 4 and somehow try to rewrite 4 over here in terms of either 8s, 32s, combination of those, or somehow with 6s. Now, 4, hopefully you realize 4 is really just 32 divided by 8. According to our properties of logarithms, we can take the log of the 32 minus the log of the 8. Log base 6 of 32, we have that approximation here. We'll plug that in. Log base 6 of 8, we have that approximation here. We can type that in. Now we can go ahead and subtract these two numbers, and we get our answer.